Hello everyone, I hope you guys are doing well over our break. In this video, we're going to do a quick recap of sequences, which is the first part of Unit 4, just to review really quickly before we continue learning new material. Okay, so we're taking a look at some notes today on sequences. Sequences can be thought of as just a set of numbers. So just a set or collection of numbers. And there are two types of sequences that we're learning about in this unit. First, we have arithmetic sequences. And secondly, we have geometric sequences. So first, just a quick recap of the notation that we're using. A sequence term number is its position in line. So term number, you can think of as the numbers spot in a line or a list. The term value is the number itself, the number value itself. So the term number will often denote as n. The term value will denote as t sub n, the nth term value. For example, if we had a quick set of numbers or sequence that looked like this, 1, 3, 5, 7, and so on. N represents the position in line of each number. First spot, second spot, third spot, fourth spot, and so on. And then the corresponding term value is the number itself that is showing up. So N is its spot in line, T sub n is the value of the number that is in that spot in line. When we're talking about sequences, our domain is always going to be natural numbers. And that's because when we talk about the position in line, and again, domain is concerned with n, the term number. When we're talking about position in line, we don't really have a 1.5th spot or a -1th spot. We're only looking at 1, 2, 3, 4, 5, and so on. So if you think about a line at a grocery store where people are standing 6 feet apart, of course, for social distancing, we might have one person right at the cash register, one person 6 feet behind them, but we don't have one person in between those two people. So that's why our domain is natural numbers. Our range can be any real number, so all real numbers, for example, for range. So these are the words that we use to describe sequences. The two types of sequences are differentiated by what we do to get from one term value to the next. An arithmetic sequence has a common difference. So we add some fixed value, which we call d, the common difference. To get from one term value to the next. So what this looks like is if we start off with 3, our next value is 5, 7, 9, and so on. Here we have an arithmetic sequence because to get from one term value to the next, we are adding a fixed value, and that value is 2. We add 2 each time to get from one term value to the next term value. Geometric sequences are similar to arithmetic sequences. However, we're looking at multiplying to get from one term value to the next. So we multiply by a fixed value. And this is often denoted as R, our common ratio. To get from one term value to the next. So an example of a geometric sequence would be if we add 2, 4, 8, 16, and so on. Here you can see that we are multiplying by 2 to get from one term value to the next. So r is 2 in this case. To find these term values themselves, so finding this third term value, this fourth one, and so on, we can use equations to help us out, or some formulas to help us out. First, looking back at our arithmetic sequences, our formula for finding a term value is t sub n, the nth term value, is equal to t sub 1, the first term value, plus n minus 1 times our common difference, d. So n is the nth term value, and then d is our common difference. So here's our equation for finding a specific term value for arithmetic sequences. For geometric sequences, we have our equation t sub n equals t sub 1, and here we're multiplying by r raised to the n minus 1 power. So we can use this equation to find the nth term value quickly. Finally, with sequences, the last aspect of sequences that we'll talk about are means. And again, there are two different types of means. Means can be thought of as the missing numbers or the missing term values between two given numbers. So for example, if we look at an arithmetic mean, we're looking at the missing term values between two given numbers in an arithmetic sequence. So the arithmetic mean, for example, one arithmetic mean between 5 and 15 can be set up as kind of like a puzzle. We're looking at 5. We have one missing number in between, and then the last term value is 15 here. So we're thinking about what do we need to add each time to get from 5 to our missing value to 15. In this case, we're adding 5. So 5, 10, 15. So the arithmetic mean between 5 and 15, we would say is 10, that missing number in the middle. Geometric means are exactly the same, where we can set up a sequence and we're finding those missing term values between two numbers. And we can find more than one mean also. For example, if we're being asked to find two geometric means between 2 and 16, here we can set up our sequence 2, comma, and then we have two missing numbers in between, and then 16. Here we can see to get from one value to the next, we're looking at multiplying because it's geometric, multiplying by a common value or common ratio. And that common ratio would be 2. We multiply by 2, multiply by 2, and multiply by 2, we get 2, 4, 8, 16. So here, the two geometric means between 2 and 16 are 4 and 8. Those are two means in this situation. And we can find these by using our formulas. So for example, you could plug in 16 as the fourth term value and then use our geometric formulas that we saw up above. That would look like 16 equals our first term value, 2 times our common ratio to the fourth, n is 4 minus 1 power. And that's how we can find our common ratio of 2. So a quick recap, we learned about sequences, or did a recap on sequences in this video. First, we learned about what terminology we use for sequences. The term number is the value n, in other words, the position in line that we have for our number that we're talking about. The term value is the actual value of that number itself, t sub n. So the second position in line, we have 3 in this case. We talked about arithmetic sequences where we're adding some fixed value. which we call our common difference, to get from one term value to the next. Geometric, similarly, we are multiplying. Instead of adding, we're multiplying a fixed value, common ratio, to get from one term value to the next. Finally, we talked about means. Means are the missing term values in between two given numbers if we set up a list of numbers or a sequence of numbers. Arithmetic means are looking at an arithmetic sequence. So we're going to be repeatedly adding the same number, and we can set up our two numbers and then put the spots in between to find our mean. Geometric means, similarly, we can set up our two numbers and then plug in the number of means, the number of missing spots in between, and we're trying to find what numbers satisfy a geometric sequence. So we multiply by the same value each time, and in this case 2, to get from one term value to the next.